Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So today's challenge is a simple problem on sliding window, is a basic problem on sliding window. But if you are new with this approach, it would be a good practice for you. So definitely try this on your own and then continue watching with the video. And I really apologize for not uploading yesterday's video. I do get a lot of views on hard videos, but still yesterday's video would have requires me around 3 hours of work of uploading, editing and stuff like that, but I had some weekend plans with friends, so yeah, that's why I just couldn't upload yesterday. But let's see today's daily challenge now. Okay, so the longest subarray of ones after deleting one element. You are given a binary array nums and you can delete just one element from it. Return the longest non-empty subarray containing only ones in the resulting array, and return 0 if there is no such subarray. So you definitely need to remove 1 0, right? It is told in the question you are given a binary array of zeros and ones, and definitely you need to remove 1 0 in order to get a largest contiguous sequence of 1. So there will be some clumps of 1 and some clumps of 0. 1 0 you will delete and you will try to find which is the longest continuous sequence of ones. Okay, so let's say you are given an array which looks something like this: 1 1 1 0. uh, let's say 1 0 is there and some more zeros, and let's say something like this is there. So you see, if you try to delete one element, if you try to delete this element in particular, you will be remaining with 5 ones. Okay, and if you try to remove this 0, you will have a continuous sequence of 7 ones. So this will be optimal to delete and my answer will be 7 in this case. And if you delete anything from here, you will not get any improvement in your previous answers. Okay, so the highest continuous sequence of 1 will still be 4, which is lying over here. So you just need to delete 1 0 and have the largest contiguous sequence of ones. Okay, so if you try to think this approach, this will be a simple sliding window problem. So what will be your window? What will be your window? You are allowed to take, you can think it in this way that instead of contiguous sequence of ones, your sequence of the subarray which you are selecting must have at most 1 0. So this is a feasible subarray. This is also a feasible subarray. This is also a feasible subarray. Okay, now you see which one length is maximum. So you see the length of this whole thing is 6, the length of this whole thing is 5, the length of this whole thing is nothing but 8, but there is 1 0 which you will delete it later on. So you have 5, you have 1, so you just subtracting the 0, and among them whichever is the highest, 5 4 7, the highest is 7, right? So 7 will be our answer. In this way you need to solve this. Okay, so you need to have a concrete approach for it. Okay, so what should be your approach? Your window, what will be your window? You can consider your feasible window with all elements with maximum 1 0, with max 1 0. Okay, so you can take all the elements with maximum 1 0, that will be your feasible windows length. Okay, so what will you do? So you will select the first 0, so you will keep iterating. You have a variable I. Okay, so you just keep iterating. Whenever you get the first 0, you just set a flag. Okay, let's say a flag was 1, you just set that flag to 0 and tell that I have taken 1 0 already, and you keep extending the window. So it will be like your window length is 1 here, it's 2 here, it's 3 here, it's 4 here, it's 5 here, it's 6 here. Okay, so you get a length of 6 over here. And when you move to this element, you see that your flag is right now false. Okay, if you are having a 0 and your flag is also right now false, so what you can do, you will not change your flag to anything, but you will have a previous variable. So at the previous 0, you just mark a pointer prev. Okay, that will be storing the value of the previous element. So what you do, initially you have this window length, but if you go to this 0, you just cut down your window to this. Okay, so now right now your window will be something like this. And if you try to see this with a better example, if you are getting confused, I will give you a better example to visualize this. So let's say I have this right now, and this 0 is also there, okay, and sun 0 with this, okay, so and so on. So what do you do? At first you have a variable, okay, you take your window length to be this, okay, and whenever there is a 0 you add a previous pointer, okay, which it will take account of the previous 0 which is there. So you have a previous equal to I pointing at this when you are at this window, okay. So right now your window length, the window length is 6, right? But as you move to this pointer, you see that there are two zeros which are there in your pointer, and you can remove at most one zero. So what you will do is that you will shift your left pointer, okay, so whichever is your left pointer, you will shift it to the previous value. If you shift this to the previous value, and what is the length now? You see the length is nothing but this I minus prev, okay. So let's say this is what, 1 0 1 2 3, this is right now 3 4 5 6, and this is 6. So 6 minus 3, 3 is your length. Why the 3 is the length? Because your window is now starting from here and ending at the current pointer, so your window length is right now this. And you, as you go on further, there is one, even if there is one, without doing anything, you just increment your window length, okay. So you just to take it like this, okay. So you, when you reach here, again you do the same thing, you change your previous value. When you are here, you already change your previous value, right, to 6. Now you go to the next 0. As you are going to the next 0, you are finding that right now my window length is what, 1 2 3 4 5 6 7. So right now it's 7, but you need to shift your pointer to this place, okay. So that's because just the 0 after this, because we want to include this 0, so we have to remove the previous 0 from our window. So this is what you will be doing. So now you will see that at this you are having 8 elements in your array, okay, in your window, and that is the maximum which you will be getting, okay. So you can do it in this way. I hope the approach is at least clear to you. So what are all the things you need? Okay, so the thing which you will need is the variables previous, okay. You need to have an answer, and every time you need to update. Whenever you get a 0, you just need to update your answer with the window length, okay. And so definitely you also need a window length, okay, and also you need a flag which will tell you that for the first time include the 0. No need to shift the previous pointer because you don't have any previous pointer, okay. So no need to, I mean, for the first also you will shift the previous pointer, but don't need to update the answer and anything, because you can include this one, you can include this one. The previous tells me whether I can include or not, it or not, okay. So where this flag tells you, okay, whether you can include this element or not. So this answer you can just update, so you know that you require these 4 variables and just nothing else, okay. You can just iterate through the array with a simple I variable also. So what you will do, you will have nums dot size, okay, and you have some elements. What are those elements? You have a flag which I will set to 1, because at the first 0 I am allowed to take that without questioning anything, without updating my answer. Also I need to update my answer to 0. I have a window length, okay. This window length is initially it is 0, and the previous element is pointing to nothing, so I will just make it 0. And what I do, I will have another variable which will go through the entire array, and if there is a 1, it will not ask any question, it will simply update the window length, right? So every time we will try to update the window length. But if my nums of I becomes 0, okay, so if it is 0, I need to do something, right? So if it is my first 0, so if flag is true, okay, if it is my first 0 which I am encountering, then what I will do, I will not ask any question, I will simply flip the flag. I will simply flip the flag. I will update my previous pointer. Previous pointer I will update it to I, current element, okay, and I will do nothing else, okay. I will not update the answer. I will, this will simply go out and update this window length, okay. It will also update this window length. Else, if it is not my first element, I mean, if it is not my first 0, what do I need to do? Definitely I need to update my answer, okay. I need to update my answer to this, not count, to this window length, okay. But you need to remember to make the previous equals to I here also. And what will be the count? What will be the window length? Window length will get updated to previous minus I, okay. I minus previous, because I is the greater value which you are currently right now, and I minus previous will be your window length. So if you are in this particular 0, 6 minus 3 is your window length. So this 1103 length of this thing is nothing but your window length. Okay, and you also update the 0, update the I, and at the end also, at the end you also just update your answer for one last final time, because if you do not get, so you see, you are updating only when you are getting a 0, right? But for the last one, if you do not get a 0, you are not updating, but your last clump of ones with 1 0 can also be a maximum, right? So you just update this. Okay, you just update this with window length. One thing you need to remember is to continue, because in this thing you are changing your window length to the current one. Okay, but you do not need to update it right now, so you don't want your pointer to reach window plus plus. What I'm trying to say is that when you are at 6, your previous is 3, so you get a window length of 3, because 6 minus 3 is 3, and you do not want your window length to update right now. Okay, you do not want it to update, and so you get some answer, and you just simply return answer -1. Why -1? Because the 0 you just took. Okay, so what did I say? This window can contain all elements with maximum 1 0. Okay, now but you need to get rid of that particular 0, right? So you just get rid of your answer -1. You just get rid of 1 0 which you considered in your window. Okay, so that is what you need to do. Let's see if it works or it does give some error. You see, we get the accepted thing. If you try to submit it and check, if you try to submit it in index, it is simple O of 1 solution, so it should definitely work. You see, we have 100% runtime complexity as well as a very good memory runtime, because our complexity is really good. It just gives me in 1e5 is the limit, and therefore I just took O of n solution. It is a simple linear solutions, and this was a very basic sliding window problem, and it is helpful for beginners in sliding window, and you will be able to understand the sliding window approach, typical sliding window approach problem. Okay, so yeah, I hope you learned something new with this video, or it was some good practice to you. So yeah, that's all for this video, I guess, and I hope you have a very easy day ahead. Enjoy the weekend. Thank you so much.